Okay, so welcome back to our tutorials for SPSS statistical analysis for survey data. So at this point, we will be proceeding now to our next set of statistical tools, which will include the correlation matrix and regression for SPSS. So let's do a quick recap. In the last session, we did the factor analysis, and before that, descriptors and frequencies. So at this point, we are assuming now that all of our variables are of good quality and we are good and go to proceed to our next set of analysis. So just again, this is our research model. So the next step is like let me pull our SPSS file here is to create what we call mean scores for the variables that are included in our study. Now these mean scores will now serve as actually these uh, these variables. So let's get to it. I did uh, yeah, I did take the time off screen to already include the mean scores for some of the variables for a study, so that just to speed things up a bit. But we're going to do the mean scores for the last two variables on user satisfaction and perceived benefits, as we've seen in this model. Like I said, since we did not do any factor analysis for the control variables, there's no need for us to get the mean scores for these. The purpose of this mean scores we'll see in a little bit. So for now, let's just focus on how to do it. So let's go back to your data file. Oh, make sure again that the items that we're going to use for these mean scores are the ones that we keep after factor analysis. So I have this table open as well, so that it will be for easier reference. So let's get to it. We go to transform, and then we compute variable. This window will now pop up. So we will have, first of all, that we will do is to type our target variable here. So this is user satisfaction. So let's use something like user satisfaction. All right, so we get the mean score of that. So in this numeric expression window that we see here, we will type mean, open close parentheses, and then we will be looking at these numbers. So since this is a mean, it's just an average, it doesn't matter how you put them into the numeric expression. So we're just gonna do like 1 US1 comma US2 comma US3 comma. All right then, so that's the mean score, and then you just click OK, and then when you go back, there you go. There's user satisfaction. That's the basically what you're calculating here is the mean number of all of the rows that are associated. Yeah, all of these three you see here. So for, let's say, for example, for the one for perceived usefulness, that's the mean score of these four here that you see here. So we're gonna do it. So it calculates it row by row or respondent by respondent for this whole column here. So let's do the other one now for perceived benefits. We just repeat. I'm just gonna reset here. We're gonna have a variable of perceived. There you go. Benefits. And mean, and in this case I think all five were let me look at my file again here. All five are included. Yes, they are. So all five items of perceived benefits are included in this part. So let's put that one in. Again, since it's an average, it does not matter which order you put them in. So I'm just gonna put it in chronological order. Don't forget your comma. Comma there. Close parentheses. Click OK. So when you go back to our SPSS table, that's it. All right. So at this point, we will be forgetting about the question items for the analysis. We will be focusing our attention now to all of the mean scores that we see here. All right. Okay, so the next step for us is to do our correlation matrix. Now, the correlation matrix is another way for us to validate or yeah, to confirm the validity of our respondents. The interpretation of which we will be doing in a little bit. But first, let's just know how to generate said correlation matrix. So we go now to analyze, and we look at correlate, and now bivariate. Okay, so again, as always, we will be seeing this one. On the left hand side, you will see all of the variables that are available for us for analysis, and on the right hand side are the variables in which we will tell SPSS on what to analyze. So, like I said, we will be focusing our attention now on the uh, mean scores here. Okay, we'll forget the actual question items here for a while. So we'll focus attention here. So here, there are two ways to do this. First, I'm going to just run a correlation matrix for the main research variables that are included in our study. So yeah, okay. And then yeah, we can actually we can also determine the mean and standard deviation for each variable. We are at the variable level now. We have stopped looking at the item level. So for now. So we're looking at the variables now. So click OK. Oh, and there's your correlation matrix. Now, like I said, correlation matrix is another way for us to determine validity of your data. How do we do that? First of all, we want to ensure that whatever items that were stated under each variable measure only that variable completely. So that would imply that system quality to system quality has to have a correlation of 1, meaning it's perfect. If you see other correlations here from other variables that are equal to 1 as well, then that means that we have a problem in the way that our respondents understood the data. I mean the question items, because we do appreciate the fact that there are some overlap in the meanings in quality. Let's say quality, we have 3 dimensions of quality here, but for some reason, there will be overlaps in the way we define each of these variables. So that's okay as long as there's not too much overlap. So as you can see here, system quality has a correlation of 1. Information quality to information quality also has a correlation of 1, so on and so forth. So this diagonal part here you see, that's totally fine. Now what we're going to be looking at further is the correlations of each variable to other variables as well. So yeah, as long as this is okay, we don't see any other figure 1 there, then we're good. All right. Now, some textbooks would mention that there are 3 levels of correlations here. Like if the correlation is somewhere from 0.1 to 0.3 or 0.4, that would mean low correlation. If it's between 0.4 to 0.6, 0.7, that means medium correlation, and like 0.7 to 0.9 is like high correlation. Now, that implies of how much overlap there is. So, and we might run into some problems later on if you do encounter a lot of these very high correlations, as you're also seeing in this particular table right now. So yeah, but it's a way for you to further report how valid your numbers are. Okay, so that being said, now we proceed to the main event of this exercise, and this is on regression. But before that, I would also like to see I would like also to show first another correlation matrix. I apologize for that. Sometimes other papers would also include the demographic variables in your correlation matrix. So let's see what happens if we do that. So we've just simply added the demographic variables here. So when we do another correlation matrix here, then you will now see here, you now see how your demographic variables correlate with the rest of your variables. Now, normally for a lot of studies, the demographic variables are treated as control variables, meaning that the expectation is that they would not pose any significant effect or significant correlations with your study variable. So normally that's what you want to see here. So So, and how what we're seeing so far in this particular case, yes, indeed, there are like the demographic variables have nothing or a very little correlation with the main study variables. So that's what you want to see typically. All right, so now it's time for us to proceed to regression. So it's analyze, regression, and then we go linear. Now, I'm going to show you different ways on how to do linear regression and, of course, discuss a little bit the implications of choosing a particular method of doing regression. So for this part, we're going to start off simply. So let's see our model again, and we're going to try to regress perceived usefulness here as our dependent variable. And we're going to look at information quality, system quality, and service quality as the direct effects towards perceived usefulness. Just as an example for this video. So let's get to it. So we go back and then we'll click on analyze regression, or I think that I already have opened it in that. Okay, there you go. So we're gonna look at, again, we're gonna focus our attention on our mean scores that we just calculated earlier. So we're gonna look at perceived usefulness as the dependent variable here, and we're gonna look at system quality, information quality, and service quality, and we're gonna put that here in the independent space here, or block if you want to call it. So this is like independent variables block here. All right. Now we're gonna stick with enter method for now. I'm going to show later why. What's the implication of using enter method? So, but for now we're just gonna look at statistics. Here's estimates, model fit. Let's look at collinearity diagnostics and Durbin-Watson. Again, once we see the table, I'm going to explain what each of one represents. Okay, so that's it. That's all you need to do now, and then you click OK. And there you have it. So the first thing you want to notice is this model summary. Now, for the model summary, you want to look at two things: the R square and the adjusted R square. These are our model fit figures. The threshold for this is you have to have an R square from an adjusted R square of minimum of 0.100. So based on our results here, we're really good. Like we're at 0.79 in this case. All right, and then of course, the Durbin-Watson is like a measure of multicollinearity. So normally some texts will put it as between 1 and 2. So we're looking at 1.8 Durbin-Watson. So that's totally fine for us now. Now the next one that we want to look into is the coefficients table here, which will describe to us the effects of each of the independent variables towards our dependent variable perceived usefulness. Now, when using the enter method, you are assuming that all three independent variables, or all of your independent variables, happen at the same time, and the effect of each one towards your dependent variable are pretty much like, okay, you just put them all at the same time. So what we're going to look at first are the beta, the t-value, and the significance, or the p-value. So for the beta will tell you how much influence it has. So it's like saying that for every 1 unit increase in your system quality, for instance, perceived usefulness will go up by 0.32. Yes, these are sign sensitive. So if you see a negative sign here later on, that means it's in the opposite direction. That the value of your dependent variable decreases for every increase in your independent variable. So we can see here that, just to repeat, perceived usefulness increases by 0.532 for every 1 unit increase of system quality. That's how you interpret it mathematically. What's all more important for us also to see is like the t-value, which is supposed to be greater than 1.96, and the significance value, which is supposed to be less than less than 0.05 in order to say that the influence of your independent variable towards the dependent variable is significant. So we can see that all three of them are like very significant. All of three have p-values below zero point zero 0.05. So you can actually say that whatever hypothesis there is between system quality and perceived usefulness is supported. So it's like normally saying like the hypothesis is like system quality or information quality, system quality, service quality are all like positively influence perceived usefulness, and your data, your SPSS results show that. So yeah, and then the collinearity statistics here. Normally, the value is supposed to be less. It really depends on that. So normally, you don't really use VIF that much. Some would ask for it, some would not. So it's really better to have it there than what. Normally, VIF supposed to be less than 3, less than 4. It really depends. I'm not really too keen on using VIF as a report to report it in whatever research I'm doing. So yeah. All right. So that's when you're using enter method. So let's try using a different method. So again, we go back to analyze. We go to regression, and then we go to linear. Let's use the same uh, set of independent and dependent variables, but now we're going to use stepwise method. That's the difference that we're going to see here. And for that, I am adding another statistic here, and this will be R squared change. You'll see it later when we do it. So when you do stepwise and then you click OK, and we see now by using stepwise method, what SPS does is that it inserts step by step the independent variables that you are seeing in your model one at a time. And if it does find out to be or determined to be significant, then it will add it to the model. And then for the model 2, you will see it's system quality plus information quality. So that's telling me that SPSS determined that information quality is significant as well, as you can see here. And of course, when you put all three, it will be the same as the one that we saw earlier. Now, the same criteria will be used, but I want to focus more on the implications of using stepwise versus enter. At least when you do stepwise regression, you would see how each variable changed whenever you introduce new variables to your model. So that's what you're seeing here right now. So system quality, when you put system quality by itself, it's 0.887. But when you include information quality in that equation, from 0.8877, it drops down to 0.648 because information quality now is at 0.264. Now you also notice the degree of significance based on the t-values also drop. It's 42 in model 1, and in model 2 system quality's t-value drops to 16. It's still significant because the p-values are all 0.000, so it's not really that bad. It's really more, but between the t-value and significance value, I'd always go for focus more on significance value, because that really tells me what's the level of significance that my variable exerts over the dependent variable. So you can see now that eventually when you put all three together, this is what we get, which is similar to what we had earlier when we did the regression for enter method. So you see it's almost the same, if not totally the same here. All right. So one more thing that I would like to show here. Okay. I'm going to add a block here, so you can click on next to add a block. It's going to be the same dependent variable, but I'm going to add my demographic variables. I'm going to keep it at enter method. That's the only thing that changes. Everything else will remain the same. And this is actually the way for you to test your control variables. So again, like I said, normally what you want is that your demographic variables, okay, your demographic variables will be, okay, will be not significant, and you want a lot of the influence of your study to be coming from your main independent variables. So as you can see here, with the introduction of the demographic variables, my betas and my t-values for my main study variables change just a little bit, and that's totally fine. And in this case, I can also see that my gender, age group, number of years, and monthly income are have very small betas, not really significant t values and p values. So this is what I like, what you want to see. Typically, what you want to see, like your control variables have nothing to do with your main study variables. So yeah, so basically that's it for doing regression and all, but we're just touching on how to do it for direct effects. So yeah, so that's how we do it in SPSS. In a bit, I will okay. In a bit, I will also be showing to you another way to do factor analysis and regression and the correlation matrix and regression, but using a different software. And then afterwards, we will be focusing on how to do moderating and mediating effects as well. So, okay, I'm gonna cut off the video here. I'll see you in a bit.